Advent of Code, day 21. That's not bad. This is... Okay. So I don't actually even want that. Oh, 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 that's interesting. Ah, okay, okay. So this is multi-level. Okay. That's interesting. So, okay. Um, this is another pathfinding. So there's another pathfinding. So we have... Okay. Mm-hmm. Mm-hmm. Okay. Turn this into a graph. So, A. Okay. Okay. Mm-hmm. Hmm. And they've got to be the shortest sequences. Okay, so I actually have that. Okay. Yep. Uh, yeah. Then we've got positions. 2 is going to be. mm, Okay. So then here it is. Okay. So that's our 2 graphs. Okay. So I've got that. Keypad move sequences. Then is um so I've got that. Um, yeah. So we start at A, right? Yeah. Okay. Um, yeah. Okay. We need to get there. Oh, that's interesting. But we might need a longer sequence for that. I'm gonna assume we don't. I'm gonna assume we don't. That's fine. Okay. Why? Values. Ah, right. And it's not iterable. Int? What do you mean int? Oh, right. Wait, no. What? Did I mess something up? Yield path dist. Find shortest paths, find shortest paths. Oh, that's just wrong. How did I not notice that? Okay. Oh. Um. Oh, well, it's better. I shouldn't have closed that. That's not what I'm looking for. Proceed. Yeah, that's right. Sessions are. The keypad graph goes from graph start and function heuristic. Yeah. Is return. Oh, I updated this, didn't I? Okay. Okay. I'm gonna have to clean this up. Oh, right. And then, yeah. Um, um, fine. Oh, the parts already are tuples. Okay, so it's Wait, key error 2 comma 3. Why? Oh, because your key comma position. Making so many dumb mistakes. Okay. Oh. Okay. No, no, no. Okay. The shortest sequence. This I'm doing wrong. I'm doing that right. Also, this I did wrong. Shortest sequence. Just make sure that's advancing. It is good. So now except each path is going to be unique. Um, that's where we start. Then we go, 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 go. Then we hit. Yes. Yeah. Okay. Yeah. Okay. Okay. So. Yeah, right. Just have this. One. One. That is to the left. This is up. That is down. Then at the end we yield A. Interesting. Oh, why do I have duplicates? How in the world did I get duplicates? Um, hope this doesn't come back to bite me. Okay. All right, I've got my first level. Finally. Um, so that can go away. And now I just need to do this for the second level. And hope. Oh crap, we need to do this at 3 levels? Oh, this is bonkers. Okay. This is absurd. Thankfully, I can extend this. So we have this. So that's the shortest sequences. So that's good at least. Now we do the next level. Possible keypad. Path to directions. Path to directions is good. Alright. So then that's fine. All of these start at 8, right? They have to. Okay. Do that. Yep, your position's 2 and 2. 288 and 28, which is okay. And that is how many? 144. And I've got that sequence. Okay. This should actually be here. Okay, I think I've got my. Do you even finish? Um, in a reasonable amount of time. That's what I was afraid of. Because this now gets really dumb. Um, actually, so how long is my sequence? 3K. K. So many candidates. That's a lot of candidates. But if I did this right, then we will hopefully. One such sequence is that. So I actually only need one such sequence. The problem is to guarantee I need to generate all of these, which sucks. In part 2 is going to make me add even more robots, isn't it? I don't even care. I don't even care. Length of the shortest sequence. Okay. So I don't care what I care about, actually. Don't do that. So assuming that's good, then we have um 68, which is correct. I don't do that. I don't do that. Okay, this is going to take some time. Let's just see. And you know what? It's going to take some time. So while it's going, sure. Good. That verified that. Now we go over here, get rid of that, and we run, and this in parallel is going to get, hopefully, my answer. I'll get it a little behind. 68, 69, 80. This is good. No, because that was set up for... Why is that one taking longer? I don't like that you're taking longer. Really don't like that you're taking longer. Um... Really don't like that you're taking longer. This, let's see. They start as sequences. That. There's that. What are you even stuck on? I don't like how long that is. That's not the right input. All right. Okay, I have finished. Well, so we'll keep you running while... Nope. I want some stats. So here I only have 12 to check. Which is why you're not bad. Got 5 total. 96. No wonder you took so long. Um, oh, that's gonna be terrible. That's gonna be so bad. Um, it'll finish eventually. Let's see. Yeah, it'll finish eventually. Out of curiosity. Holy cow, people have already finished Brew 2. So repeats are best, actually. Repeats are best. So we actually want to prefer repeats. Meaning, yeah. What if the shortest sequences to double check. Yeah, that's not the one that's not this one. Um, yeah. So if I do that for both of these, that's good. Oh yeah, look, that's better. That's significantly better. Though it's still kind of slow. 70, 140, okay. So that is one thing that improves. One thing I still don't know is, so I needed to make this a set because I had duplicates here and I don't understand why. Okay, well, I got part one at least. Please tell me. I knew it. I was afraid of this. So I guess one thing I could do. Let me also save that just in case this was the good solution. Let's take you, replace with that, and then over here, when I am possible move sequences, let's only return move sequences with the best repetition. That's the thing, actually. Each individual that's interesting, actually. Between every few buttons, I have to press A. That is my target answer. That's my target answer. Every few buttons I have to press A, meaning there can only be repetition within a given one of those. So the question is, so far this looks like it's computing the same thing, the right thing, which is good. I'm going to cancel that because I don't think that matters. Because I think this is the important part. I want to maximize repetition. And here I want to actually select whatever has the least movement. So it goes from A over, does the sequence, and then goes back to A. Yeah. Yeah. So actually, oh, I'm so close to thinking about this properly. I am so close. We have, let me just sketch this out. This then expands to this. And really, we should think about this as those separated, because each of these are fundamentally independent. Being fundamentally independent doesn't matter because, yeah, they're independent. And so this actually turns into a okay. So I think actually, because these are independent, um, that was the right answer, right? It was. Good. Okay. These are independent. Yeah, that. And copy both of these. Here, repetitions of A are the absolute best. Because then it's just one. So we see here yep. So this then expands to this, this, that, that. That expands to that. Nope. That. Keep hitting the wrong thing. No, I lost track. Yeah, we get a cycle. These two. Yes. So one thing, actually, because this has to go back to A, I don't care which of these it is. I don't care which of these it is. I don't think. Do I? I don't think so. I don't think so. Also, monkey bat move sequences. Right. Oh, and then, okay. No wonder you're not helping much. Invalid answer. Okay. You're invalid. That's why. What is the correct one of those? 70, 140. Yep. 76, 176. Yep. Yep. Yeah. Oh, that's irksome. It was almost right for all of these. Master repetitions. What if I always have to go back to A? So instead of that, instead of this, okay, okay. You've had two sequences, shortest. Gonna be that. We are not going to do that at all. Because of because one of the, yeah, there's always an optimal one of these, I think. Small keypad from start to end. Yeah, that's what I want. That's what I want. Assuming this ID is even right. So then this is the same as basically this. Do I even need that? I don't even need that. I do need this though. Oh, that got worse. Um, that got way worse. Do I really need to do this at 2 levels for each subsequence? Um, mm, yeah. So we'll do 2 levels here. Just gonna be questionable. because there's only so many of these sequences that there can be. So while it'll be annoying to calculate, once it's calculated, this should then recursively be perfect. And it'll be cached. So the furthest away we have to go is left, left. Unless I just want to manually calculate what the optimal moves are. But that sounds like a pain. Okay, left to 0. 1, 2, 3, 4, 5. So my worst is 1, 2, 3. Or is it 1, 2, 3, 4 is my worst? 1, 2, 3, 4, 5. A sequence of 5 buttons is my worst. There's a sequence of 5 here, which is right, down, 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 A. The optimal sequence here is going to be up, left, left, A, up A, right, down, down, A, right, A. Left, left, A. Right, A. Up A. Down, down, A. Right, down, down. Down, A. Which is my worst one to calculate. Even though the sequence should be fine. And then right A. 5 is up, up, left A. Oh, is it up, up, left A? Or is it left, up, up, A? Oh, but this gets worse, actually. Because on this keypad, down, left, left, A. Right, right, up, A. Actually, down, left, left isn't too bad. This is taking an extraordinarily long time to compute. So is this one right? So I probably should do is. I should only get a single sequence out. Which will hopefully be ideal. And hopefully be optimal. So what I should do is I need to go through 25 robots. So, right? Just double check. I'm using one. 25 robots. Oh, there's 26 directional. That's mean. The other root thing. Oh, yeah, look at that memory usage. Okay, fine. Fine, I'm onto something here. I'm onto something here. What if we go back? So if I just did this, which is what exploded, it gave me the wrong answer. Gave it to me really quickly. But those are wrong. Yeah, that's wrong. That's wrong. Any of these right? Ew, no. See, this was no, that was identical. I thought I tried that and it didn't work. Wait, I'm getting different answers. Oh, that's interesting. So it's not deterministic. Okay. So let's make this deterministic. Okay, you're deterministic. Good, 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 bad, good. If I were to do... Oh, wait. So it's actually only that. Oh, wait, no. Both of those got affected. Okay. So, my question here is, with... want to maximize A's. I want to maximize A's followed by characters neighboring A. Okay. So up or right. Do that. Interesting. I thought I was going to be onto something. So if I go between... I could be going down the entirely wrong thing here. A lot of people have finished at this point. Oh, those two have actually only managed part one, or at least for top 100. Or any any particular sequence has a cost. Which is the number of buttons we have to press and how many buttons the higher level has to press that. We know we always minimize the higher level. So if I can compute, do I even need to compute? Or can I hard code? I can hardcode this. How am I trying to do this dynamically? If, this, okay. I'm gonna be a little annoyed if this is it. Um, A up, the cost is left, and then A. So the cost is 2. I think I can actually. So path to directions. I have path to directions 2. Where's path to directions 2? Wait, or was it keypad 2 graph? Alg score. Or keypad 2 seek. But no, I want start and end. This. Um, nope. And then this is. Wait, isn't it just that actually? Yeah, it's just that. And calc rep score of a sequence. Oh, right. Why is that all? So I need to go to the next level. Minimize. But mhm. is 2. AA is 2. AA shouldn't be 2. Mm. Oh, find shortest paths. From you to yourself. Oh. Okay. Those are correct. Those are trivially correct. That's left and up. Down. 1, 2, 3. A. Yeah. Mm-hmm. Mm-hmm. So those are all right. Those are all correct. Of course, I would have loved to have had an answer to this example. Oh, there's the example. Mm-hmm. Yeah. I'm gonna have to write this at some point anyway. Oh, I know this is wrong, but just protect myself. Um, for each. That's it? Yeah. Should only get a single candidate. Mm-hmm. All right. Just in case you go haywire. breaking down on 10. Nope. Yeah, so that's wrong. You're growing annoyingly fast. The most annoying thing here is I am pretty sure I am on the cusp of the answer. And I am just missing something. Because that's what I thought. I thought we were going to then, for each pair, minimize that pair's delta. That would make sense, and that's what I'm trying to do here. And honestly, this I could optimize. In fact, I should optimize. So what if actually sort of sequences? I don't do that. Yeah, I skip that on that level. So here I then need to this might be a better idea. Okay. Okay. Oh, possible. Do this. Let me just double check. This is dealing with. Yeah, great. I've got a good feeling about this. This is explode key two presses. As for my nomenclature, top level. Now, yeah, that's getting so expensive to do. Reveal. Oh. Aren't you all passable too? Yeah. Okay. No. All possible keypad sequences. Oh. Did I? Yeah, but that's fine. Wait. Oh, right. Yeah. Yeah, sure. Fine. Every single pair goes back to A. It must go back to A. Must go back to A. So, that's not right. That's definitely not right. Uh, okay. Did something wrong here. 10. Why are you 10? That's actually what you should be. $24. Oh, it's improving, but wrong. Why am I getting these duplicates? I need to. Yeah, I'm getting unique paths here. Wait, what am I using down here then? For sequencing that. L. Duh. Okay. Okay. Right. So that's good. Is it because I'm not doing this? It's probably because I'm not doing that. Because all sequences start at A. Okay. 26. 38. No. No. No, that's not right. It's almost right. So let's see. Start here. 229A. All of them start with that. Then we start with that. Then we've got those, those. So these are all generated correctly. It takes 28 total to do that. So we've got 10. So that's good. Except for the fact, okay. Oh, okay. And then I do this. That's 28. That's 68. Is that correct? That is correct. That is correct. Okay. I need a 60. Okay. 26. I've got it. I've got it. Got it. I've got it. Okay. Where's part one? So then, essentially that is the num levels. Wow. Where am I printing that? Where's my prints? Nope. You go away. You're. Where am I starting? Oh, right. Yeah. But here. Yeah. Right, right, right. So answer is that for line and that. Line. That's correct. Great. And then if this 26. With no assert. No! How are you too high? No! Okay. There was one directional keypad robot. There's me. Oh, that's so frustrating. I thought I had it. Oh, that's wrong. Oh, wait, no, that's not wrong. That is correct. Yeah, 70, 76, 72, 70, 66. Yeah, I calculate those very quickly now. Then these are quick. But you don't like that answer. Even though each pair is independent, right? Each pair should be. Up here, we have yeah, so there's this, which gets converted to this, and then 2 levels of directional input. Here, there is numeric, then 26 levels of that. It's not going to be that. Yeah, that's what I thought. And this one you said was too high. Why? Also, how many people? Ooh, I'm not doing great. You specifically said it's too high. Double check my assertion here. For one level, so at each level we start at A. Start at A. I want at the next level to press up. I take care of the directions to move the button there, then I move back to A and I press A. At this level, I start at A, I go back to A. That is that. That is that. That is that. All possible. I'm not even. Wait. Wait. Go back down here. Maybe. Count key presses 2. Find best sequence. Pick one of these. Count this. Or count this. Count 2 key presses. It goes through all this, which is unfiltered. completely. This is obviously the right approach. Actually, back that up just in case. This is 100% the correct high-level approach. Let's delete things I don't need. Don't need that. Don't think I need that. No. I don't need scoring. I don't need any of you. I don't need the pair costs. You, I think I need. Yeah, you I use that. I shouldn't be using this anymore. I do need the rest though. Yeah. I need that. I need that. Okay. I don't need you. Okay. Less to deal with. Same answer. These are all. So at any given level, I start at A. I do stuff to move the robot. Go back to A, press the button. Which gives me a clean break. At that level. Is there ever a point where we want to take a suboptimal sequence at one level for a deeper level to then be shorter? Wait. Wait. 5-bit sequence. That. Wait. Count key presses to achieve. A to B. Wait. Wait. did it say about this? Answer is too high. I'm on A. Yeah, so if at the deepest level I need to press an A, and I'm already on A, I just press an A. That just keeps going up. That doesn't increase. That is correct. That is absolutely correct. If I wanted to go from the up arrow to the down arrow, thinking about it actually, yeah. So I subtract one there, and then I keep subtracting here. Yeah. Yeah. And that makes sense because that does flip-flopping. Yeah, so let's just take that. Start at A. Go down, left, left, A. Right, right, up, A. So that expands to that. For, and each of those is independent. Then we just focus on this. A. Left and down, sure. A. Left. A. A. Right, right, up, A. How do you not like my answer? Find the fuse number, but process you need to perform some of the complexities of the 5 codes on your list. You don't like that. I know I did. I know I did. Anyway. I see. I accidentally switched, which was reference, which was not. Sorry. You go away. Yeah, so if we do this, but what I want to do is 28. Does 28 sound right? Is this 28 long? Yeah, it is. Now I did. You're gonna say that I submitted this as well. It's too high. How is it too high? Is that? No. This over. Yeah, it's 2.4. That's suspiciously close. Um. Just for my own curiosity. Well, at least other people on my own leaderboard haven't finished. What about this one? Yeah, I figured he would. Each press is independent. That's what I figured out here. It's supposed to be 2 or 1. 2 means go here. 1. Here. 0. 2. Yeah, so actually, sorry, you should be that. Mm-hmm. Sixty-eight. Yes. So what if wait, that's not even valid actually. That's valid. This one's not. From A to 1. Sorry. Up, left, left. Up, left. That's correct. I got so lucky in part one. Okay. Left, down, left. Down, left, left. That's correct. Okay. Point six. Okay. Um, Let me check. So in the first one, I hit, which makes a directional robot hit, which makes a directional robot hit. Okay. So this one might actually be. Okay. Okay. Ooh. That was a beast, and it ate me for dinner. Um, I'm also very surprised I got part one solved. Let me just clean up. This is gonna need so much cleanup. I need that, and I need Funk Tools, and I think that's it. And I don't need the prints anymore. Okay. I do need code that is significantly less awful, but that can come later. So, how much did I miss the leaderboard? You know what? I'm I'm glad to be done. Glad to be done at least. Um, so I'm one of those. Yeah. So let's talk about this beast of a problem. Um, so there are multiple levels of complexity here, and they all stem from I want to press a button sequence, but I need to tell a robot to go to that button and press it. Um, would be I'm actually a little surprised that part one already had us doing multiple levels, but okay. So yeah, if I need to press 029, I need to move over to left one, press that button, then up one, press that button, up two, right one, press, down three, press again. Um, then we take that sequence, which is one of these, probably that one. Yeah, that one. Uh, and then because we can't have an easy life, we actually have a robot between us and the actual keypad we're trying to input the number for. So actually, we need to put in numbers on this keypad, and on that keypad, go and and press the the right things on our keypad to make the intermediate robot press the right things to press that. And then, of course, there's a third level. So part one, I believe this was my awful code. My awful code with the bug where my keypad 2 graph was actually just my normal keypad graph. I got so lucky here. Um, so my strategy for part one, which was an awful strategy, but it worked even with this bug, was just generate all the sequences for each level and keep the minimum length sequences. And as we keep the minimum length sequences, eventually we'll get to the end and we're keeping our memory footprint down somewhat. This did take quite a while to compute. It was very, very bad, but it got me the right answer eventually. This did require multiple levels of mapping though, because I need to know, I need to have a graph essentially for each of those keypads and know, hey, I want to go from say A to 2, what's the path I should take? Now I could have sat down and hand computed all of these, and frankly, that probably would have been better. I probably would have been done way quicker if I had done that, but I didn't. So yeah, I was converting these into graphs, and to do that, then I need to know for each key what position there is in this graph. So I was just creating this mapping here, and then we've seen before, I really like my lib.graph library. I can make a neighbor function and just in compute, okay, where should I go? So it's pretty simple. We've got this this grid, so I've just got some conditions here to keep it in the grid and skip the blank space here. So yeah, that gets me my keyboard, or my my final keypad graph. My keypad 2 graph was just this, and a slightly different mapping. And the annoying thing is, as we've already seen, I had this bug for a very long time, where my keypad 2 graph was the wrong one. But with those two graphs, then I can just have a couple of functions that take a start key and an end key, convert these into positions in the graph, go and find the shortest paths from the from key 1 to key 2, iterate over them, handle them. Oh, that is right. I also had bugs in my graph.py that I fixed. So that was fun too. But yeah, just iterate through all the shortest paths in the coordinate space. And then once I've got the coordinate path, I need to convert that back to a direction path. So go through, take each delta as I'm going along the path and convert that into a direction key. And of course, at the end, I need to actually press the key that I'm trying to press. So that's that for the keypad, and I think I've got the keypad 2 move sequence as well. Shortest sequences, was this even used? It was. That's right. So then shortest sequences. I was just trying to expand the sequence, my input sequence, the very nice clean number and A at the end, and expand it into the shortest sequence to press that one meta keypad up, one of these keypads up. So just go through, iterate through all the possible move sequences, keep track of them. I don't even know why I was sorting these. So yeah, I had to put these in a set for. Also, that is one thing that was weird. I don't know why I needed a set here. I think I was seeing duplicate candidates at one point here. Never did track that down. But yeah, just get all the shortest sequences using the possible keypad move sequences, one key at a time. So moving from A to 0, then 0 to 2, 2 to 9, 9 to A, etc. And possible keypad 2 move sequences is the same as possible keypad, but just with the keypad 2 graph, the meta keypad. Same thing for shortest sequences too. Same deal as the first keypad, just here. And then with all that, part one was just run with those two, or with those set of functions, to just do these multiple steps. Take my input line, get the shortest inner sequence, then the shortest outer sequence. I did a shortening here because at this point I saw it was already bogging down and I didn't want to bog down any further. Wanted to prune down this set before I did the final layer. I did that, and this still took, what, like a minute, 2 minutes, 3 minutes, something like that to compute. It was pretty awful. But it did give me the answer eventually. Through dumb luck, I've said it a couple times now already, but I'll say it again. I'm really baffled as to how that didn't break things for me. Because that is not the right graph. That is just not the right graph for this meta keypad. Anyway, so then we got to part two, and things fell apart really badly. I was trying to kind of keep this same strategy, but figure out, okay, which of these sequences is the best one overall to keep, which I guess conceptually you could do, but at the same time, that is a giant string. How big would this have been? 106 terabytes, if I'm counting correctly. Yeah, 106 terabytes worth of key presses. Now, granted, it would have been on one of these levels, so let's do that over. Wait. Oh, sorry. That's not key presses. That's already been manipulated. Still, this longest sequence, 84, 85 kilobyte, or gigabytes, not kilobytes, those are very different units, gigabytes worth of characters to store the key presses. So that, yeah, my initial idea of doing the same part one strategy, optimizing how many candidates I had at each level, never would have worked. I do not have 85 gigs of RAM to spare. So I was fumbling a very long time trying to optimize that. I think it was probably going on to probably like 130, 145 when I finally realized, wait a moment, fully realized each of these key presses are independent, which actually makes this problem much more tractable. I was kind of getting glimpses of this earlier, actually. You can see, was it over here? Do I have any remnants of my scoring? Yeah. So over here, I was trying to score, hey, when we've got sequences, we know repeated key presses are going to be easier to compress. Like, fundamentally, this is actually a compression problem in many ways. Because we want to see which of the key press sequences compresses best when we go up the next level. And if we've got to go from 0 up to 8, that's going to be pressing up the up key 3 times. And then if we go up one level beyond that, pressing the up button means we just go over and we press A 3 times. So as we've gone up 2 levels, we've now compressed this sequence up maximally. If we were to, now of course this is kind of silly, it makes more sense if we're going like A over to 8, where we want to do either left and then straight up, or straight up and then left, because either way, we've got the 3 up presses just in a row, so that the 2 levels up, we've got a robot just sitting on this key, and it's just hammering that button 3 times in a row. perfectly compressed. If we instead go up, left, up twice, 2 levels up, it's got to go over here, press the up, then move. Press left, move again to up, and that's just more expensive. So I had glimmers of that when I was trying to do this scoring and figuring out which sequence was going to be shortest. And as I was analyzing this, I was starting to realize, wait a moment, each of these subgroups here, and by subgroup I mean like this or this. I guess strictly speaking more like this. But each of these subgroups is independent because at every single level, the robot's going to start on the A button, going to have to move over, press some buttons to move the next robot in, the next depth in. And then at the end, when it's moved that next depth in robot to the correct button on its keypad, the robot on our level goes back to A. So if we've got robot, let's call it robot 0 at the top level, and robot 1 at the inner level, and we need to move robot 1 from down over to left, we know always, doesn't matter what context it is, robot 0 is going to be starting on A. So it then has to move over to the left arrow, or rather it needs to send a left signal and then send an A, so that the robot 1 moves over and hits A. Doesn't matter anything about the remaining sequence. Robot 0 always starts and ends that sequence at A, and that's true at all the levels. So once I finally got that through my head, I finally started on the correct solution here, which is treat each of these groups independently and just make a memoized recursive check. Now this check is really awful. I really need to clean this up, but the core idea here is just for every pair of buttons at one level, at say level 1. I'm going to keep calling level 0 at the higher level, level 1 at the deeper level. So at every delta, every move on level 1, I can figure out at level 0 what is the best choice and how many key presses is that. So that's fundamentally what this is doing. It's also keeping track of how many levels we have to go. And all it does there is it just iterates every possible way to do that move sequence, to go from this first button to the second, and just score the cost of, okay, how expensive is it? Keep track of the best one, return it, and since this is memoized, then next time we ask, we'll get that same answer. So that handles all our levels of the special keypads, the directional keypads. And at that point, we just have one final level, the top level, where we can iterate all the possible keypad move sequences for the top level string, like 0 to 9, go through this for all the subsequent levels, and then get our answer. So yeah, that took me way too long to wrap my head around. At least I've finally got a solution, and yeah, this is definitely a problem where if you get an answer to part 2, you have the correct algorithm. There is no brute forcing this beast. So yeah, it'll be interesting to see how many people do manage to solve this one. This one definitely was one of our tricky ones for the year. It definitely beat me. My butt got kicked. So yeah, I'm gonna have to try in the next couple days to see if I can get any leaderboard points for this year. I've got 4 more days. I would really like to get some points before this event ends, because I've gotten points every other year I've participated, but we will see. Um, yeah, hopefully we get some other interesting problems, and hopefully I can figure them out a little quicker than I did today. But yeah, that's about all I have. Uh, yeah, this code is really ugly. I will be cleaning this up. Yeah, that's all I got.